Welcome back. 8.3 chapter is on quadrilaterals. Today we're specifically going to go over rhombus. Okay, so a rhombus, there's a few different ways to speak of this. It's really a parallelogram that was upgraded by one of the following. Okay, so what happens in a rhombus, the most popular idea is that all the sides of a rhombus are the same. Now, a parallelogram can have that, but it doesn't have to. In a parallelogram that's not a rhombus, you could have something like this, 11 for these two sides and 15 for these two sides. Now, you'll notice opposite sides do have to be the same, but not all four for a parallelogram. In a rhombus, okay, what we have is all four sides are congruent. Another shortcut to that is just to say that it's a parallelogram where the adjacent sides are congruent. So that's another way to look at it. Okay, the next property, that's an upgrade. In a parallelogram, you have these angles. Okay, let's say we have angles in the interior angles. Let's say it's a parallelogram. Let's say that that's a 70-degree angle, which would make this 110. Okay. Now let's say we also have this in a rhombus. So this is a parallelogram. A rhombus can have the exact same angle measures. Say it's 110. That obviously makes the other one 70. So that's 110, this one's 70. However, in a rhombus, here's the difference. Diagonal has to bisect that angle. So it has to perfectly be 35 on either side. Now, if it's a parallelogram with a 70-degree angle, that doesn't have to happen. You could have 20 on one side and 50 on the other. So the diagonal does not have to bisect the angle in a parallelogram. It does have to bisect the angle in a rhombus. Okay, so you're going to get 35 here. If that's 35, then some of that. Okay, so we're going to see some problems come up with that concept there. All right, the last property that is an upgrade. You go back to this. This angle in here in a parallelogram does not have any specific measure that it has to be. Okay, so this one could be 105, right? However, the diagonals intersect and have to create a 90 if it is a rhombus. So what we're going to end up seeing quite a bit in this chapter, very popular question, because that happened, we're going to get some Pythagorean Theorem problems. So I might tell you RM is 10 and HS is 24. So we could give you the diagonal lengths, and this is a really popular question. You'll see it in the examples. What a student has to know to do is cut the diagonal in half because the diagonals bisect each other. Any parallelogram does that. So R to F is 5. H to S the whole way is 24. So F to S is 12. Since the diagonals create a right angle, here's what you're seeing now. You're seeing a right triangle. So knowing the diagonals, we can actually figure out a side. And that's what they're going to have us do. So Pythagorean Theorem, 5 squared plus 12 squared equals c squared, or in this case, x squared. And so we would be able to get the side length from that. Very popular question. So let's go through some of the types of questions you might face on the assignment. All right, that's good enough. I'm going to backtrack a little bit. I'm going to come to this proof in a little while. That'll be what I finish with. But what I'm going to do is I'm going to squeeze in some questions that are similar to those that you're going to face. first one okay, so we're looking at perfect. There are two. Okay, so a parallel question. So let's say they tell us that this is a rhombus, okay, and then they tell us that this is a 64-degree angle. Now, they want to know the measure of this angle right here. We'll call it angle 1. How do we approach it? Well, it's really two steps. Okay? In a rhombus, it's just like a parallelogram. These two angles right here are consecutive angles. They have to add to 180. So basically what we could do is 180 minus 64. Okay, so we know that 116 goes there. And we know that the diagonals have to bisect the angles. So then we'll take 116 divided by 2. And we get our 58. So measure of angle 1 would be 58 degrees. So you'll see something like that on the assignment. Okay, another one like that. Slightly different. Okay. So again, we'll give you a rhombus. All right, this time they'll have, and they'll tell us that this one is 71 degrees, right in there. Okay. And then they'll ask us for that angle measure right there. Okay, so here comes the process. A couple ways to do it. If it's a rhombus, we know these two sides are the same. We know these two angles are the same. So if that's 71, and so is that. This is a right angle. Okay, we're getting there. So is that. Based on alternate interior angles, you could have a 71 there. And I could pull that apart. So here's my right angle. Here's 71. And now I can add the three angles in this triangle to 180. Okay, so 90 plus 71. This is one way. I'm sure there's a quicker way that you'll find. Okay, so that measure of angle x. So x equals 19 in this case. Good enough. All right, one more style that I want to talk about, and that's if they were to give us the length of the diagonals. So, they give you a rhombus, ABCD. Now, you don't have to have the drawing to know this. All they have to do is skip a letter. Okay, so in rhombus ABCD, okay, let's say they tell us it's a rhombus, AC will be 16, BD is 30. Now be careful, they're going to say find the perimeter of rhombus ABCD. Now, that's how they will tell you it's a rhombus. They'll hide it right in the problem. They won't tell you it's the diagonals. You have to know that if you skip a letter, in the 4-letter path they give you, if you skip a letter, then that indicates that it is a diagonal, right? So they're not going to give you the picture. That's something you had to come up with on your own. Now, what you have to know is these two diagonals bisect each other. Now, my angle does not look like a 90. Drawings are not to scale. They don't have to be. If you draw that and it doesn't look right, nobody's going to care. If you throw the right angle in there, even though it doesn't look like it, you've expressed to the person scoring, you know what you're doing. All right, cut the 16 in half, that's 8. The 30 in half, that's 15. Now, You're noticing that I'm just going to get one side and it wants perimeter. We'll get there. Okay, so let's run the Pythagorean theorem on this. Now, we have the length of one side. There's 4 equal sides. So that's what I would do right there. Perimeter is 68.